Okay, here we are doing 5.4 of this trigonometry part of this supplementary paper. And let's just say prove this identity. We're going to prove that this side equals this side. Well, you know, there's a trick with this one. You know that we have the cosine of the sum of two angles. We look at this thing. Let's start with the left-hand side. And the trick is instead of making it the cosine of 3x, make it the cosine of 2x plus x. Then you just apply the formula to that. It's really cos 2x cos x minus, you see you switch it, sine 2x sine x. I'm just using the formula for the sum, the cosine of the sum of two angles. And now, whoa, this opens up a lot of good things. You see the sine of 2x is really it's 2 sine x cos x. The sine of 2x is really 2 sine x cos x, so I just replace it. The cosine of 2x, now I'm looking at where I'm trying to get to, this 4 cos squared. I have 3 to choose from, but I choose the one that's got cos squared in it, 2 cos squared minus 1. And then a lot of good things start happening. We end up with this cos x canceling with this cos x canceling with this cos x. We have 2 cos squared x minus 1 and minus 2 sine squared. Well, let's just take a look at this. This sine squared is really 1 minus cos squared. That's right from our first grade 11 identity. And now we're minusing 2 times a minus. That's plus 2 cos squared. That's going to give us the 4 cos squared. In fact, that's what it is right there. You see you go minus 2 and then plus 2 cos squared x. Well, minus 1 minus 2, there's your minus 3. And 2 cos squared plus 2 cos squared is 4 cos squared. It looks really complicated, but the trick to get started was to see that the cosine of 3x is really the cosine of 2x plus x. And then you can use that sum of a cosine, the sum of the cosine of the sum of two angles. You use that formula, and then everything else just falls out. You had to use quite a few identities. That's why it's so many marks. Okay. All righty.